Picture this, a single, simple line of code. That's it. And that one line has been the key to some of the biggest digital heists in history. It's kind of like a 20-year-old ghost in the machine, and it's still finding new ways to cause all sorts of chaos. So let's dig in and see exactly how it works.
All right, so to really get why this, well, ancient trick still matters so much, you've got to understand the sheer scale of the damage we're talking about. I mean, this isn't just some minor bug. It's like leaving the vault door wide open.
Okay, get ready for this number. 16 billion. In June of 2025, that's how many user credentials and passwords got leaked online. We're talking one of the biggest data dumps in history, just a massive, massive collection of logins all just out there, ready for the taking.
And listen, these logins weren't from some forgotten website in a dark corner of the internet. Nope, we're talking credentials from the absolute titans of tech: Google, Apple, Facebook. This whole thing was what we call a credential stuffing bonanza. Basically, attackers take these huge lists of stolen logins and just try them everywhere, hoping to break into other accounts. And it was all fueled by malware and, you guessed it, previous data leaks.
And it wasn't just the big tech giants either. Seriously, the list of victims reads like a who's who of global business. You've got airlines like Qantas, software companies like Red Hat, even the Move It transfer platform got hit. And that one was bad. It blew up into a massive ransomware campaign that hit over 2,000 different organizations. It just goes to show you, nobody is immune to this stuff.
So, the big question is, how? How does this keep happening? What is this surprisingly simple weapon that hackers have been using for decades to cause literally billions in damages? Well, to figure that out, we've got to look at the code. Okay, the culprit has a name, SQL Injection. Or if you want to sound cool, SQLi. It's a classic attack. The best way to think about it is that it turns an application against itself. It basically tricks the database into following malicious orders that are cleverly disguised as just normal stuff a user would type in.
All right, let's break it down. Here's a normal login. You type in your username and password, right? The application then sends a little command, a query, to the database. It's basically asking, hey, database, can you find me a user where the username is admin and the password is password123? Pretty straightforward. Simple enough. Okay, now watch closely. This is where the magic happens. An attacker comes along and makes a tiny change. Instead of a normal username, they just type in admin dash. That's it. A single quote and 2 little dashes. Believe it or not, that is the entire key to the vault. So what's so special about that little sequence, dash, dash? Well, in the SQL language, that's a comment. It's like telling the database, hey, just ignore everything that comes after this point. So the command completely changes. It now says, find me the user admin. And that's it. The entire password check, poof, it's just ignored. It's commented out. And just like that, the attacker is in.
But wait, it gets so much worse. I mean, logging in is one thing, but attackers can use other commands, like union, to do more than just get in. They can steal everything. With this kind of injection, they can tell the database, okay, give me the normal search results, but also, while you're at it, just tack on, or union, the entire table of usernames and passwords too. It's like asking for a book and getting the keys to the whole library.
And this is the really critical part to understand. This attack isn't just about looking at data. An attacker can literally extract everything. They can change records, they can delete entire tables, or they can even go further, escalating their privileges to get complete remote control of the server. And from there, they can plant backdoors, these nasty little scripts called web shells that give them access whenever they want.
Okay, so right about now, you're probably thinking, hang on, this is a 20-year-old problem. Surely we've fixed it by now, right? And the answer is, well, kinda. But here's the crazy part. The same fundamental flaw behind this old trick is now popping up again in the most cutting-edge tech we have: artificial intelligence.
So what's the connection? Well, the real weakness, both in the old SQL attacks and these new AI hacks, is that the system gets confused. It can't tell the difference between data, stuff it should just read and process, and instructions, stuff it should actually do. And that confusion right there is the key that unlocks everything.
And you can see that connection perfectly right here. On one side, you have SQL injection, where the attacker's input gets mistaken for a database command. On the other, you have AI prompt injection, where an attacker's prompt tricks the AI into just ignoring all its safety rules and following a whole new set of malicious instructions. You see, the underlying flaw is exactly the same. The problem is, with AI, the consequences could be way, way bigger.
And this isn't just a theory. In fact, the UK's National Cybersecurity Centre, these are the experts, right? They've issued a pretty stark warning. They're suggesting that because an AI model, a large language model, basically sees everything as just more text, its own rules, your input, all of it, this flaw might be baked right into the system. It could be an inherent vulnerability that we might never, ever be able to fully fix.
Okay, so that whole AI thing is, it's a huge challenge for the future. But there is some good news here. For the original threat, for good old SQL injection, we actually have a solid, proven playbook for how to defend against it.
And this is really the key point. Unlike the AI dilemma, SQL injection is a completely preventable vulnerability. I mean, yeah, it still happens, usually because of simple mistakes or old, outdated code. But for all intents and purposes, this is a solved problem. So what are the steps? How do you lock that vault for good? So there are basically 4 critical layers of defense. The big one, the absolute number one, best practice solution is using something called parameterized queries. It's a fancy term, but all it means is you force the database to treat user input strictly as data, never, ever as a command it should run. That's the silver bullet. Then you combine that with other smart things, like validating what people are typing in, making sure accounts have the least amount of power they need, and sticking a good firewall in front. You do all that, and you've built a pretty formidable defense.
All right, so we've looked at the past of this attack and we've gotten a glimpse of its future. So what's the big idea here? What's the most important thing to take away from all of this?
Well, ultimately, this isn't really a story about SQL or even about AI models. It's about a conceptual flaw. The real vulnerability is in any system, one we have today or one we'll build in the future, that can be tricked into confusing simple data with a command it's supposed to execute.
And that really leaves us with a final pretty big question to think about. Our whole world runs on code now, right? From our cars to our power grids. So as we build these more and more complex systems, we have to ask ourselves, where is the next injection point going to be? And more importantly, are we going to be ready for it?